Bismillahirrahmanirrahim. Hello and welcome to Rahman Digital Production. This is lecture number 55 of Physics 5054. In this lecture, we will discuss and will further extend our knowledge to the concept of simple kinetic theory of matter. Yesterday we were discussing problems related to kinetic model of matter and we did two questions. Today we are going to discuss third number question and so many more. So let us directly jump into the world of these questions. Remember that we are in section B of the structure questions. Ladies and gentlemen, third number question is saying distinguish between the three states of matter, namely solid, liquid, and gases in term of, this is very important. Number A, the movement of the molecules. A part is saying what is going on in solids and liquids and similarly in gases. In terms of the movement of molecules, if we are, I was checking the mic, so it is turned on. It's okay. So in terms of the movement of molecules, in this case the molecules movement is about the mean position. They are vibrating about the mean position, about the mean position. Here they are moving also freely. They are moving freely. In this case, the liquid case, they are moving freely. And in gases, they are also moving freely. In case of liquid, they are bound with each other, but because they can slide over one another, so it means they are free to move. And because in the cases of gases, they are further apart and there is no attractive forces between the molecules, so they are moving freely as well. In case of the liquid, you can say that it is freely because it can slide one another and it can spill further apart. So that is why I wrote it. You can say that the molecules movement is restricted, but because they are sliding one another, so that is why we are saying that is the first part. And in the second part we are saying we have to differentiate the spacing of the molecule, so tightly spaced, they are held together with very tight attractive forces. They are also held firmly and they are further apart. They are not bound to each other. Okay, they are, you can say here that they are in the form of clusters. So, one cluster is holding the molecules firmly together. That is why I wrote here held firmly together. In this, they are tightly spaced. Here, the cluster are tightly spaced, the density is more. Here, the density is very high. Here, the density is also high. Here the density is not that much high. So that was in term of the uh, spacing of the molecules, their volumes and shape. The third one, we have to differentiate between solid, liquids and gases in term of shape. They are having fixed shape, fixed shape and fixed volume. Yes, they are having fixed shape and fixed volume. They are having fixed volume, fixed volume, but not fixed shape. Shape is not fixed. In whatever you are putting it, it will be getting the shape of that container. Here, no fixed volume, no fixed volume, and no fixed shape. No fixed volume and no fixed shape. So we are differentiating solids, liquids and gases on the basis of these three different properties, and we did it. Hopefully you have understood. Question number 4. In terms of the kinetic theory of gases, explain why pressure exerted by the gas increases when its volume reduces at a constant temperature. Uh, when this is according to the Boyle's law, that pressure and volumes are inversely proportional, because pressure is inversely proportional to volume. And the question is saying this as well. When we reduce the volume, the pressure will increase. And I given you an example that if there is a container which is having a piston above it, now this is the gas inside that container, and when we increase the pressure, I'm taking it in another context, that if we are increasing the pressure, for example, if we are putting three pistons on, three weights on it, so it means that the volume will decrease. When the volume is decreased, pressure is increased. When the volume is increased, pressure is decreased. So both are inversely proportional to each other. And why it is happening according to the kinetic molecular theory of matter? There are molecules inside it. So when we are applying force externally by putting a weight on it, so it means that they will get energy from outside the force which we are applying, and they will be closely packed. So it means that the pressure will increase. Let me give you an example from daily life. If there are 3 people or 4 people and you are pressing them, you are decreasing their volume. So it means that they will feel pressure on their cell. In similar cases, when you are decreasing the volume, the pressure will increase here as well. So each and every molecule inside the container will feel pressure if you are putting a weight on it, which in turn will apply a force. So this is due to this particular phenomena we can explain that pressure is inversely proportional to volume. Okay, that was the fourth number question. Now we are coming to question number 5, and they are saying that the volume of a fixed mass of gas is 760 millimeter of Hg. So V1 is equal to 760 mm of Hg. Similarly, further they are saying is the volume is 1500 centimeter, sorry, this is P1, and V1 is equal to 1500 centimeter cube. 1500 centimeter cube is the V1. And similarly, if we are further moving in this question, so they are asking what is the pressure. So we have to find P2. So what is the pressure if the volume is reduced to 1000 centimeter cube? So V2 is reduced to 1000 centimeter cube. According to Boyle's law, we know that as we know that P1 V1 is equal to P2 V2, and because we have to find P2, so we will make it as a subject, and we will P1 V1 divide by V2. Now putting the value, P1 is 760 and V1 is 1500 and this is 1000. So these two zeros will be cancelled with this one, and this 10 will be cancelled with this one. So we will only be left with 15 6 are 90, 15 7 are 105, and 115 millimeter of Hg will be the pressure. So that is the ultimate answer. Now we are going to do question number 6. Question number 6 is saying in A part, a sealed flask contains a gas. Keep in mind this. Part number 1 is saying that describe the motion of the gas molecules. Ladies and gentlemen, they will move randomly with high speed. With high speed. They will move randomly with high speed. Is narrated by Robert Brown. So we are sticking to that point. Number second part, explain how the motion of a gas molecules result in a pressure exerted by the gas on the wall of the flask. When they are exerting, when the molecules are getting energy from external source, they will collide with each other and with the wall of the container, and as a result they will exert pressure on the wall, pressure on the wall of the container. Yes, in this way they will, and this they will exert pressure on the wall, and we can explain these things to simple kinetic theory of matter. Now the next B part is saying this was in A. There were two parts. Now we are turning to B part. Explain what is meant by Brownian motion. The haphazard, yani random, the haphazard motion of molecules inside the gas is called Brownian motion. Next part 2 is saying, with the aid of a label diagram, describe the experiment to demonstrate Brownian motion. That was part number 1. This is part number 2. See lecture 52 and 54. In both of them, we discuss this experiment in greater detail. In yesterday's lecture, we also given a touch to the experiment. So I'm not wasting the time here. If somebody is interested in greater detail, they can go to those part. Now there is C part, in which they given us a graph. On x-axis there is a volume per meter cube, and on the y-axis there is a pressure per atmospheric pressure. From 0 the pressure is increasing to 3, and then 4.2, and then 6.2, and the volume is given only one time, and that is 0.6. From A part they are gradually decreasing what? The pressure. The pressure is gradually decreasing, sorry. Yes, I told you that this is gradually decreasing. Here at A point it was 6.2 atmospheric pressure. Then at this point they are having the value as 4.2 atmospheric pressure, and here there is 3.0. So it means that it is gradually in decreasing, and here there is 0.6 meter cube the volume of this A at A point. At B point the question is asking to find the value. The graph shows changes of pressure and volume at a fixed mass of the gas. AB represents a change taking place at a constant temperature of 20 degrees Celsius. BC, which is this one, represent a further change for the same mass of the gases. Now we have to turn the page and see the question, and that is use number one part. Use the graph. Use the value of pressure and volume given on the graph to calculate the pressure, the volume at B. This is the first part. We have to find. Now, if we see, then P1 is given as 6.2 atmospheric pressure. And there is V, and that is volume. So V1 is equal to 0.6 meter cube. And in this case, the second case, the P2 is 3.0 atmospheric, and we have to find V2. Nothing difficult is there, as we know that V1 is equal to P2 V2, and that is Boyle's law. Because we are finding V2, so we have to make this V2 as a subject, and P1 V1 divided by P2. So it will be P1 is 6.2, V1 is 0.6, and here we have to say that P2 is equal to 3.0. So 6.2 multiplied by this is equal to 3.72. 3.72 divided by 3.0, and as a result we will get 1.24. 1.24, and because this is volume, so we will take the unit as meter cube. Now the second part we will take like this. The second part explains the nature of the change represented by BC. So there is abrupt change in the pressure while the volume is the same. So this BC is not increasing like this. It is abruptly increasing because there is no change. The same volume at B and the same volume at C. But the pressure is increasing from 3 to 4.2 without any change in the volume. Ladies and gentlemen, in the A level and at the graduate level, BS level, you will find there are four methods. One is called isobaric, isocuric, an adiabatic process. So there is a one process in which the volume is kept constant and there is a change in the pressure. But we are not going in the detail that how, but just giving you a taste that you will understand. Here they only wanting us to tell about these changes that sinks. So this is abrupt change in the pressure very quickly. The volume is the same. So this is showing this. Now question number 7 is saying that the left hand diagram above shows the equilibrium position at 0 degree Celsius. Sorry, this is question number 8. Now we have to do question number 7. An inflated car type is considered to have a constant volume regardless of any change in temperature or pressure. No pressure is increased, no temperature is increased, the tire is inflated, at constant volume. Volume is the same of the gas. Regardless of any changes in temperature or pressure, use the kinetic theory of gases to answer the following. A number part. A number part is saying that how does the air in the tire exert a pressure on the walls of the tire? According to simple kinetic theory of matter, molecules moves randomly, colliding with each other, and exerting a pressure on one another and on the walls of the tire of the car. Yes, when they are colliding with each other, they are transferring energy to one another in the collision, and when they are getting energy from one another, and when colliding with the wall of the car tire, so they are putting pressure on that rubber inside the tire and they are inflated. Number B part, why is the pressure the same at all points on inside the wall of the tire? The B part is saying why, because of the uniform motion of the molecules. Because no external pressure is given, no temperature change is there, so it means that the volume, the pressure will be the same at all points on inside the wall, because the question is saying that there is constant volume regardless of any changes in the temperature or pressure, so it means that they will move uniformly. Now, the C part of this question is saying what happens to the pressure on inside the wall of the tire if the temperature of the air increase. Explain your answer. The molecules will get energy and will increase the pressure by hitting the walls rigorously. So they will put pressure. Now, the D part, more air is pumped into the tire while the temperature is kept constant until there are twice as many molecules as before. Explain why you would expect the pressure to be double. The volume double, for example, it was these 6 molecules at the beginning. They are putting less pressure. Only this will put pressure, this will put pressure, and this will. Now, if we are doubling, it becomes 12. So, more molecules will put pressure on the walls, and as a result, the pressure will be double. More molecules injection will cause to put double pressure due to its high density. The density will be double. Now, question number 8, the final one. They are saying that we cannot left this question for tomorrow. We have to do it and we'll finish this, and tomorrow we will start the next unit. Okay. The left hand diagram above shows the equilibrium position at 0 degree Celsius of a thin rubber sheet sealed over the open end of an empty wine glass. There is a wine glass here on which, if you can see in red, I denoted there is a rubber seal above, and this is at 0 degrees Celsius. While they are putting it in a heated chamber, so the temperature rises to 65 degrees Celsius. Now the first part of the question is saying that the glass is placed in a heated cabinet in which the temperature is 65 degrees Celsius and the atmospheric pressure is unchanged. Number one part, draw on the right hand diagram above the approximate new equilibrium position of the rubber sheet. So ladies and gentlemen, they will be like this, inflated. When the temperature is rising, it means that it will put more pressure on the rubber seal and they will be inflated. So when temperature increase, more pressure will be there because molecules are getting more energy from outside and they will push this rubber seal, so it will be in the inflated form. This was the whole story about the part number 1. This was part number 1 in part A. Now the second part is saying account for the change in equilibrium position of the rubber sheet. I told you that molecules inside the glass will get energy and will put pressure on the rubber seal and will be inflated, as you can see in the figure. Okay, number third part, account for the fact that the change take place slowly. When you are putting it in the chamber, the heating cabinet, so the molecule will not get energy, will not be getting hot very quickly. Slow process, slowly the temperature will increase from 0 to 65. So slow increase in temperature will cause slow inflation. So this will be a slow process, not very quickly it will inflate. Now the final part, and that is the B part. They given us this. There is a pointer and there is a graduated scale. These are the wall of a glass and there is a fixed seal on it. This is rubber sheet. This red one is a rubber sheet. They are saying that a light pointer is stuck to the rubber sheet so that it pivots above a glass, a point P. This is point P. This is pivot at point P. Near the rim of the glass as shown in the enlarged below. This arrangement acts as a simple thermometer. State two disadvantages of such a temperature. State two disadvantages of such a temperature. It will not. The first disadvantage is it will not give you the correct temperature. Why? Because if it is inflating like this, when the temperature increase, so the pointer will point down, then instead of going it up, it will come down when this rubber sheet is inflated. So this is the one disadvantage, that it will not give you. The second this disadvantage is at higher temperature, the rubber sheet may explode. So it is not giving you, it will not be used for a high temperature measurement. So these are the two disadvantages. Thank you very much for watching. Allah Hafiz.